Hello everyone and welcome back to the channel for another C video in our C series. Now, today we are actually talking about arrays. Now that we are hopefully comfortable with pointers from the previous video, we can move on to arrays, which if you've programmed before, you would know that this is a pretty essential data structure in most programs because it allows us to group things together. It allows us to put data types together. Now, if you've programmed in Python, you might recognize arrays. They are very simple. They just look something like this. In Python, we would just create an array by doing something like this, and this is an array containing integers. Now, in Python, we were not limited to our data types. We could have characters, we could have strings, we can have floats, we can even have booleans, we can have whatever we want in Python. Now, eventually, we will get to the level where we kind of understand how to implement that in C. But when we look at the low level, which we often do have to in C, and we look at how memory is allocated, this is actually not possible. We can't have an array containing multiple different data types. So this is the first thing to note. Arrays limited to one and only one data type. Now, another difference that we can notice from Python is Python makes it very convenient for us to use arrays because we have functions like .append where we can just grow the size of our array, or there were other functions that could decrease the size of the array, and it made it very convenient because we could just add onto it. Now, again, on the low level, that's not possible. When we create an array, an array is a contiguous block of data, and what that means is that in our memory stack or heap, depending on where we are making this array, we have different addresses, and an array is just basically, like, for example, if we had an array of size 3, it would just be these 3 cells. They'd be one right after the other. Now, this fourth one might be something else. This one might end up being an integer to a completely different data type or completely different variable, and we can't just grow this array, right? And what Python does is actually, whenever you do exceed your size of the array, we just create a bigger array, copy everything onto it, and just return the address of our new array. And it does all that in the background. So you as the programmer don't have to worry about it. Now, that does come with its efficiency issues, of course, but we can get around that stuff by implementing it on our own in C. So again, arrays, fixed size. And I think we can start. Now, of course, we need our int main. Now, let's create our very first array. We'll call it ARR for array. And how we do this is, well, we can use these square brackets and we can just give it a number. Now, this number actually sets the size of it. And what we can do is just do this. There you go. And what this has done is we've allocated space on the memory stack for an array ARR with a size of 10. Okay. Now, you might notice that we said this is limited to one and only one data type. Well, how do we specify that? We specify it just like this. If we want an array of integers, we start it with an int. Now, from here, what if we want to, well, what are the values of these 10 cells? And right now, it's undefined behavior, meaning that, well, it just depends on where it's set. It could be overwriting some old data, and that data becomes the default values to it right now. But if we wanted, for example, to switch the first index, we could just do this. And then the second index, Now, obviously, I don't want to do that for every single 10. So what we can actually do is just set it equal to, and using curly brackets, we can write our values here. Semicolon. There you go. This is essentially how you set an array. Now, there are other important things to remember in this. Now, we are going to look at a behavior of, let's say, a function void double, and we are going to take an integer array as well. And here's what all it will do is, let's say, this is all it will do. It'll just double the very first one, okay? And here we can print our very first value. We do that by passing array at 0, because array at 0 is not a array data type anymore, it's actually an integer. And now here we will call double. Oh, and of course double is not it's not a word that you can use because it's actually a data type, so let's just call it double like this. And now let's pass it. And if you guys remember from earlier when we tested this, when we were learning about pointers, when we just pass a variable, well, it makes a copy of it here and it doubles it, right? Well, we will see that that's not necessarily true. %d / n and pass array at 0. And now we can compile, what did we call it? GCC array.c. Now, what did we, oh, we forgot to include our library. Hopefully that's it. What did we, undeclared first use in function. ARR0. Oh, right. We can't print that value before we actually define it. I think that should be it. Yep. And if we call a.out. Huh. Interesting. So remember, if we were to take an integer here, what C does is it just gives it a copy of this value, right? And now we said we can get around this by using pointers, right? So if this was a pointer, then we can manipulate the original data, right? But what's happening here? We didn't pass a pointer. We're asking for an array, right? Now, this is what we call array decay. And basically, passing this array through a function, well, think about it this way. Here we have a array of size 10. Now, sure, it's not that difficult right now. You just have to send over 10 items, and we just have to copy those 10 items onto a new array in the stack of this function, right? That's not too difficult. But let's say I had a function that passed in like 1,000 or like 100,000 size arrays. Okay, now all of a sudden, it's doable, but it's slow and it's unnecessary time that we're wasting on this. So instead, what actually happens is that when we pass an array as a variable to a parameter of a function, well, even though this is defined as this, what actually ends up happening is this is also just a pointer. And if you see, it does the same thing. So are arrays and pointers the exact same? Well, no, they're not. They are different, but this is just how array decay is. Now, basically, these are equivalent, this and this, but what's important to understand is that they are not the same. And why are they not the same, you might ask? Well, let's create an integer length and make it equal to size of and pass ARR. Now, what this actually does is it looks at the array, sees how many bytes it takes, right? And remember, integers are 4, and we have 10 integers, so this should return 40. And if we print it and double check it, we forgot our semicolon, like always. We get 40. Okay. But how did it know it was 40? Well, it knew it was 40 because, well, we set it as an array. But here, when we pass it as a pointer, if we were to take our int length and make it equal to size of array, and we print %t slash n, and we pass our length. Well, we also have to call it, and we pass our ARR. We get 8. Why is that? Well, it's actually because when we have a pointer here, it has no indication of how long this array is. It has no way of knowing this. It's just a pointer. And this pointer is actually to the very first item in the array. Now, also another thing you can do here to get the true size of the array, because we don't really care about 40 that much, we can divide it by how much each item takes, and this now will return 10, just as a side thing right here. And now we have how many items are in it. And this is why when we actually use any functions, well, we don't have access to size of when we pass a pointer. Instead, what we have to do is ask for a second parameter called size. It's either that, or in the array itself, we use one of the cells to indicate that it's the end. Like if we put a -1 at the end, and our function expects that that will be the end. And now what ends up happening here is that we actually have to pass this, and we have to pass length. And this is how you would know %t inside, whoops, size. This is how you would know the length of an array within a function. Now, what do we want to talk about? I think we have covered most things in arrays just to start off with. Now we could talk about pointer arithmetic. This is a very interesting topic actually, and it's a very useful one. Now say we actually want to print this array. So we switch this from double to print array, and we want to pass print array. Now if we look at our array, we didn't put any indicator on how it ends, which by the way strings do, which we will see later why we don't need to pass length. But here we don't have an indicator, so when it ends up here being here, we don't have a way of knowing the length of the array. Instead we have to pass size. Okay, fair enough. Now we want to print every single item, right? And how we will do that is we can just run a simple for loop for int I equals 0, and we want to continue until while I is less than size, right? Because at 10, then it's too big because the last index is 9. And we want to increment every time. Our curly braces, there you go. And well, what we can do is actually printf %d with a new line. And now here, what we can actually do is we have, since it's a pointer, the asterisk, remember, dereferences, so that means that it pulls the value that goes along with the pointer. Okay, but again, this only points to the very first item. So right now this will print the first one over and over and over again. But notice that I put these in brackets, and that's because we can go +1. And what this will do is it will increment to the address, so it will take us to the next address, so that would be the next item in the array. Now you might be looking at this and you might be wondering why we call it pointer arithmetic, right? Because we're just adding 1. It is like very common sense. But if you remember the addresses, these are each 4 bytes, right? So the addresses are going to be 4 apart. So if we were going to follow that logic, wouldn't it make more sense in this case to add 4 instead? And the answer is no. It's called pointer arithmetic because it automatically does that for you. It knows that this array is a pointer to integers, correct? So when you add 1, it knows that in order to get to the next one, we can't just add 1. That will just be the next byte in the integer, which is useless. We need to add 4. So what ends up happening here is ends up being 1 times 4, truly, right? But again, we don't want to add 1 either. We want to add I, because we want to start off at 0, then add 4, then add 8, then add 12, then 16. Now, again, we're not actually adding 1. We're adding whatever size this is. And we can, of course, test this. And we missed something. Right, we missed our second bracket. There you go. We were able to print it. And so that's really the basis of pointer arithmetic. It is a very important concept to understand. And that is why, if you go look more deeper into it, the way that the memory stack is set up, arrays start at lower addresses and then they increment. And that's because pointer arithmetic needs to be possible. Whenever we add to it, we want to go to the next cell. If it was the other way around, then we would be going backwards, which doesn't really make sense. And I believe that is it for arrays. Now, again, the main highlight to take away from this is, of course, how to initialize arrays. That arrays are actually, well, they are of fixed size. The only way to grow an array is to create a new one and copy your old data onto it. We are only limited to one data type, although we will talk about how to get around this or how to implement a way that allows us to have multiple data types together later on. We also talked about the difference between a pointer and an array, and that they are not the same thing, although here they look like they are the same thing. If we were to do this, I believe this will work exactly the same, even though we're asking for an array instead of a pointer, and that's because of array decay. When we're passing it to a function, they are treated the same. They're just treated as a pointer. And the difference between them is, remember, a pointer is just a piece of data that carries a memory address, correct? And That is why when we pass a pointer to a function, we also have to pass the size of that array, because that pointer holds no other information other than the start, the very first position. But an array is different because this is like a block of data, a block of data that are in sequence. It's one block after the next, and each one carries a certain amount of bytes depending on the data structure that you are carrying inside. We also, we showed the size of, and we showed how to get the true size of the array. And when I say true, I mean how many items are being held rather than how many bytes. And other than that, well, that is everything for arrays. It's a very important topic. I would really suggest that you spend some time really getting a good understanding of all of this, because almost any program you'll write will use an array in some way. Now, thank you guys for watching, and I'll see you guys in another video.